Good morning, everybody. My name is Jonathan Nitty. Sorry about that. It looked like my mic was muted accidentally, so I apologize for that little setback. But today we'll be presenting. We'll be uh, presenting today the ICM492 product webinar, and it's built off of the ICM492C, which is a current product of ours, and we will show you the improvements, the design features that we have made to improve the actual 492C into a much sleeker, much more user-friendly device. Okay, so first of all, we'll cover why is it important? What is the importance of using line voltage monitoring, and why do we need it? Why do we need it? So single phase line voltage monitors basically are a vital add-on investment to help protect equipment from brownouts and over voltage conditions. Okay. Now, what are brownouts? What are over voltage conditions? So power is not really as consistent as everybody might think. If you were to measure the voltage coming out of a wall socket, for example, the voltage would fluctuate between 115 to 120 and so forth. It's not going to sit steady at 120.0 volts AC. You know, it's going to fluctuate around because it is AC voltage. Uh, so single phase voltage monitors will monitor this drift up and down. And if you have a condition, for example, where um, everybody is using the grid and there's a lot of power consumption, sometimes you can go into a brownout condition where the power being delivered to your home or to your building is dropped very low. It could be maybe only 80 volts rather than, let's say, 120 volts. And once that power drops like that, the load wants to try to keep going. It wants to keep drawing more current to satisfy the demand. It doesn't want to stop. So it's just going to keep drawing more current till you start blowing fuses, and this can create a very damaging condition. So brownouts are very dangerous for equipment, just as over voltage can be very dangerous. We've seen this with mini splits, where the voltage range of the mini split is only maximum allowable voltage is 252 volts. And a lot of times in the US, our power grid is sitting around 240, 246 many times on an average. And then as peak periods, come in where everybody's using their equipment, the power company may even raise the grid more. And so to satisfy the demand. And so you could easily jump to 252 volts, which would damage a mini split circuit board, creating a very expensive repair, sometimes in the thousands of dollars. So protecting expensive commercial products from damaging over voltage conditions, which are common at nominal 240 volts input, is something we want to always, consider. And that's what these voltage monitors do. So they're vital for equipment that have sensitive electronic control boards in them. So line voltage monitors, again, they monitor the incoming line voltage for under and over voltage conditions. The ICM492 in particular also incorporates special features like a protective anti-short cycle timer in it that monitors when you have a loss or a fault condition, or so when you have a fault condition and then all of a sudden the fault condition clears itself, we don't want to turn on a compressor right away, for example, because if we did that in a scroll compressor where there's very little mass, the back EMF would cause the compressor to go backwards, and that can tear up a scroll compressor pretty fast. Also, with a compressor, if you were to, like, say, have a fault condition and then it shut the power off to the compressor, and then all of a sudden the condition cleared itself, you had no anti-short cycle, and it came right back on again, you'd be starting that compressor under a lot of high head pressure, and that would be very detrimental to the product. it would be very detrimental to your compressor, because you're starting up against a wall of head pressure, which can break, a lot of the internal components in the compressor, including the reed valves or any other valves that are in the unit and other parts of the compressor. It's good to note that these are wired in parallel. So this doesn't break your service voltage per se. Most of the time, what you're going to be breaking here is a control signal to like the coil of a contactor, as we see shown in the typical wiring diagram here. Now, the relay can support roughly 6 amps inductive load, but that's not going to be the typical wiring. We're not going to be typically breaking a load directly or breaking service line voltage. We are going to be breaking some control signal or some other control voltage. So this is a passive device. It's not in series with the line breaking the service. That's important to understand. Typically, it's breaking a control signal. It's also ideal in applications where we have power that's not very consistent. They call it dirty power, where you have voltage anomalies or spikes or weird things going on with the voltage that, we want to be able to see, hey, are we dipping low and then going high? Do we have a lot of fluctuations in the voltage? Then we use these to kind of protect. Again, they're protective devices. They don't condition the voltage. They don't change the voltage, but they protect. They open up a contact at the normally open and common relay at the top there. And as you see in the diagram, and we break, like, say, a control voltage to the coil of a contactor, which will save your compressor. So they, again, they're not designed to condition the voltage or break service power. They're designed to protect your equipment by breaking perhaps a control signal to your unit. They also are not designed to protect against lightning strikes. Many people think voltage monitors will take surges or spikes of voltage. They take voltage fluctuations in amplitude, meaning that the amplitude of the voltage goes higher or the amplitude dips very low. That's what it protects against. It doesn't do fast-acting transient voltages like you see with the surges. Surges are suppressed by things called surge suppressors, which we will have more videos and more webinars on those type of devices as we go along. But we recommend the use of an ICM492D single-phase surge suppressor to go along with the 492, not only to protect your equipment from those damaging surges, but also to protect the ICM492. Because remember, the 492 is also a sensitive electronic piece of equipment. So it itself can be damaged by a fast-acting transient surge. So we always recommend, whenever you're buying individual components like a voltage monitor, that you pair it up with the appropriate surge suppressor to get you the full circle of protection. All right, so the standard features of the current model ICM492. So the 492 has been a very good, solid product for us for years. It protected against over and under voltage and rapid short cycling caused by transient power interruptions. It had adjustable voltage set points, anti-short cycle time delay, as we mentioned earlier, adjustable response times for that's a fault interrogation. With over and under voltage, they consider that, believe it or not, non-critical faults in the world of fault recognition. So meaning that the voltage can dip a little bit for a couple of seconds without damaging your equipment. So to prevent a lot of nuisance trips, you want to have an adjustable response time so that you can interrogate the fault a little bit before you call it a hard fault. So we usually recommend a couple of seconds, 2-3 seconds. If your voltage anomaly lasts more than 2 or 3 seconds, call it a hard fault and then break your contactor coil voltage or something like that. It also includes a 5-fault memory. So it gives you a little history of what's going on with your faults, whether you had an over or an under voltage condition. It has universal input voltage, 80 to 300 volts AC, but you're going to be attaching 120 or 240 to these controls. Heavy duty single pole double throw dry contact output relay, and a control voltage input for incorporating a thermostat or some other safety device to give you control over when you want that relay to close. Now, that's a feature that is optional. It's not recommended, that control voltage. You can see it shown in the ICM492C picture at the bottom right corner. Again, it's a control input. It's a separate input to give you control over when the normally open and common relay will close, in case you wanted some safety device to close first before you allowed the ICM to close its contact. Again, it's an additional input, not required, but it's there in case you need to use it. So now, how does this new model differ from the old model? So we added a couple of different features in there which make it really nice. So one thing that I personally never cared for is that on the old 492C was the way the buttons worked. They had a sticker or a label that went over push buttons that were located underneath the panel. Unfortunately, that when you press on those enough, if you've ever dealt with other products that have such buttons, eventually you mash right through them and the button starts poking out through the label, and it's a mess, you know. Sometimes they stick. It's just not the best thing. So we went to tactile buttons that are actually a physical push button that works so much better. They're much more reliable and durable. So that increased durability and reliability for all your feature functions and setup. We also improved the backlight on this device. The backlight, there was no real backlight on the old 492. The new model has a nice bright backlight for low light conditions, and so that's a major feature on the 492D. We have a new microprocessor. The old microprocessor in the old 492C has gone obsolete, and we used a nice new microprocessor, which actually is rated to read a true RMS value, which means it'll read more accurately, more closer to your voltmeter readings. So by doing so, we give you more accuracy. And not only that, we have added a calibration feature that the ICM492C did not have, so that you can really pinpoint that accuracy to read exactly like your voltmeter and be a nice, very accurate display of the incoming voltage. The old 492C used an average of the peak voltages, which sometimes could drift 5 or 7 or 8 volts, where you won't see that now on the 492D. So improved accuracy, new microprocessor, redesigned buttons, backlit display that's nice and bright and readable. And also, if you notice, it's not mentioned here, but there's LED lights on the control for load energized, control voltage, setup, and fault, which you didn't have on the previous model. It makes it much easier to read, much easier to see, especially in those low light conditions. So just a more sleeker new design, new and improved features that make this just a much nicer feature for your single phase applications, voltage monitoring. All right, so what's the value proposition? Basically, what makes ours, valuable to not only our contractors, our wholesalers, and our commercial property owners. So being a leader in the manufacturing of line voltage controls, we keep innovation in mind, and we're always trying to improve our products, okay? So that's why you see this new and improved design of the 492D. Instead of the D stands for digital rather than analog. The older model was an analog device. This is a digital device with a high-end microprocessor. Some other key takeaways that we can offer here is you got superior protection. From a contractor's aspect, it protects against premature failures. and damage caused by common voltage issues like overvoltage and brownout conditions, as well as anti-short cycle, incorporating the anti-short cycle feature for protection of short cycling compressors. From a wholesaler standpoint, it's a top-selling product. It's easily manufacturable. Because it's easy to manufacture here, it supports a high volume demand. So it's great for the wholesalers. They can get them in high volume at lowered cost. For commercial property owners, it's a low-cost insurance policy for your valuable equipment. It's probably the lowest cost insurance policy you'll ever buy. So those are the things that kind of add a value to buying ICM. The other thing is trustworthy company, right? We've been in business for more than 2 decades, closer to 30, 40 years actually now. So we should say 4 decades, right? Worth of innovation and being recognized as a leader in not only line voltage monitoring, but types of controls as well. So we're a leader in the controls industry, but some of our major recognition is voltage monitoring and surge protection. So we are a leader in that industry, and you can trust that you're going to get a very well designed, very valuable, very rugged, durable product made right here in the U.S. at our Syracuse, New York facility, a vertically integrated high-end facility, ISO 9000 certified to the latest standards. So what's our competitive edge? Well, there's a couple of different ones we looked at. We could even delve into this even further, but we feel we have really one of the best ones on the market. A lot of the other ones that you'll see, they feature a couple of fancy things here and there, but the ICM492 kind of excels in some of the things that make it durable and long lasting. One of the things we look at on the 492 as compared to, let's say, the Rector Seal 96420 is that the 96420 has latching relays. Now, latching relays can become a problem if they latch on and the power goes out. They're going to still stay latched, and that may not be a desirable condition for you to be in. And so the ICM492 has a dry contact relay, much better for inductive loads and things like coils of contactors and things like that, that you're going to actually be breaking with the ICM492. DigiKey also has a wider profile, a more depth in their design. So you can see it's kind of fat and big and bulky. Ours has a much slimmer profile, making it easier to fit in the tight spaces. The new tactile buttons of the 492D supersede all of these that you see here, except for the Rector Seal. The Rector Seal does have some tactile buttons there, but most of the other ones you can see are either, press button like the old 492C, where the buttons are hidden under a label, or there's some type of a knob, which can be crude and not accurate. So I think with our digital accuracy and our new tactile buttons, I think we supersede in that as well. That we also have a nice, easy to read backlit digital display for low light conditions. You can see the Rector Seal does not have that. And we also can see that at least 3 of the 4 here do not have a lighted display. So we believe that backlit display will make the difference in low light conditions and things where you may need to see it. And the voltage and environmental specifications of 492D are a little bit slightly better than some of the competition, including DigiKey, MVA 591. So we have a few things that, like I said, that make ours more durable, easier to use, and easier to read. And we just feel that it's just a sleek, really good design for a reasonable price. So let's talk about how we can segue this into our Century 3-in-1. Our Century 3-in-1, as many of you may already be aware of, is our all-in-one voltage monitor and surge protective device, which includes a disconnect. So it's like an all-in-one stop shop for, installing voltage monitoring and surge protection for single phase. This is ideal for mini splits or heat pumps that have sensitive electronic boards in them. You just need one product. You don't have to install a separate disconnect. You don't have a lot of stuff sitting on the outside of the house. It's all incorporated in one neat package. And just a great thing is that the 492D will be going into the Century 3-in-1 as we phase out the 492C. So you're going to have an even better product in the Century 3-in-1 as time goes on. Again, it's going to incorporate the anti-short cycle to prevent short cycling of the compressors, easy to read. Again, a passive device, wired in parallel with the line, breaking a contactor. And everything is within the assembly is replaceable on this Century 3-in-1. So it's a very nice package. Of course, we offer superior technical support. We give you all the cell sheets, instruction guides, and installation guides, and wiring diagrams that you need to wire the product, and all the technical specifications and safety concerns and everything that you got to have when you're installing electronic or electrical equipment, high voltage. And anytime you need any technical support, you could call our technical support at 1-800-365-5525. And also, you can send us an email or any other information that you would like to gather from us. We can answer through email and technical support. And to understand that our technical support is live technical support. And unlike a lot of other companies that don't talk to people that are not necessarily technicians, we have a tendency to help everybody. And we try to do our best to, within reason, try to service the entire community and give you the best advice possible with a live person. So that concludes the webinar, and what we'd like to do is open the floor now up for any questions that anybody has at this time. Are there any questions that anybody is concerned with anything that we mentioned in our webinar?
Hey, I have a quick question, if you don't mind. This
Sure.
is Jamie. Listen, you had mentioned earlier 2 to 3 seconds of variation is not that big of a deal, and that might be where you would place this. I generally try to encourage people to make that much faster than that, especially when you're, up on a mountain or you're out in the woods somewhere at the end of the line. You get a lot of fluctuations. I kind of am concerned about the electronic controls I'm trying to protect with this. I just want you, if you would, just, am I wrong saying that it should be faster?
It all depends on the application. So typically with voltage monitors in general, like a little bit of fault interrogation is not typically a problem, because what you run into if you have it too narrow is you're going to get a lot of nuisance trips as the voltage fluctuates a little bit. And if that's acceptable, then absolutely you can set it. That's why we give you the ability to set it down to like 1/10 of a second.
Right.
But
and that's my concern, because I'm rebooting like computer circuit boards every time the voltage goes too far out of fluctuation. And therefore I want to catch it early and allow it time to reestablish itself before it comes back on.
Okay. So for applications like that, you might want to use the lowest setting. But for somebody maybe that's protecting an air conditioner, for example, and an inductive load like the compressor or something like that, a second or two of slight voltage variation is not going to hurt it in the least bit, because in many cases these air conditioners are built without any voltage monitoring, right?
Exactly.
And
Yep.
they're designed that way. So they're designed to be able to withstand a couple of seconds of fluctuation. But in your case, where you're protecting a different thing, more sensitive electronics and stuff like that, it may be required for you to drop it down to its lowest setting. And that's why we give you that ability to adjust it.
Oh, and that's great. The products work great for me so far. The D, I was curious to see the difference in it, and I'm happy with the changes I see. So thank you.
Very welcome. Very welcome. Anybody else? A very good question. Excellent question. Anybody else have any more? These are all good things. Ask your questions now. We also could, if you don't feel comfortable asking now, you can send us an email at info@icmcontrols.com. Call our tech support line, 1-800-365-5525. Visit us on the web. This webinar will be available, as well as other information on voltage monitoring and surge suppression. If you have any other questions. Yeah, I welcome anything, but we're coming towards the end of the webinar here. So just leaving the floor open for the last couple of minutes. Anybody wants to speak up? If not, we'll conclude our webinar. And again, please feel free to, email us or call us on our tech line. We're here Monday through Friday, 8 to 5 p.m. For technical support. We also, you can send us an email at any time at info@icmcontrols.com, and we will be happy to answer any of your questions. We hope that you enjoyed our webinar, and we look forward to presenting more for you in the future.
Thanks, John.
Thank you.